So how do we go about generating our estimates of beta in Excel? We saw the output in our prior discussions, but how do we actually achieve it? Well, let's say we've got the firm we want to generate beta for, GE. We've got its timeline of raw returns for 5 years between 2013 and 2018. And we've got accompanying returns for our single index proxy, the S&P 500 portfolio. Now, if we want to sort of do it the quick and dirty way, we don't even necessarily have to worry about adjusting by the risk-free rate to calculate excess returns, but we could. We could subtract the risk-free rate monthly from both the firm-specific and the index-level portfolio returns. But then all we really need to do is just run a regression model. So we can go to Data in Excel and Data Analysis, and that'll bring up a Data Analysis dialog. You might need to enable the Data Analysis add-in if you don't see it by default. You simply select the regression model. You can specify what the Y range is. In this case, that's the dependent variable, in other words, the returns to the firm. And we're going to highlight the entire series. And the X range, which is to say the returns to the market index. And then we can say whether we want to use labels. We don't want to constrain the intercept to be 0. Let's get confidence intervals around our point estimates, just because it's informative about their variability. And let's have the output actually go right to our active sheet. So we simply press OK, and there is our regression output. You can see it's similar to what we saw in the regression model in our prior discussions. We see what our R-square is. It's actually somewhat low for GE. Only about 25% of the variation in its returns is captured by the S&P 500. The correlation between the two is about 0.5. There's, of course, in this case, 59 observations, so 58 degrees of freedom. And what then is what are our alpha and beta? Well, our alpha is negative 0.01, so we perform slightly less than our exposure to the index would otherwise suggest. And we can actually see that this alpha is significant. The t-statistic is negative 2, and the p-value is a little bit less than 5%. And the confidence interval about this alpha is, well, in both cases below 0. It can be as low as negative 2% per month, or as high as about 3 to 4 basis points, negative 3 to 4 basis points per month. And what is our beta? Well, the point estimate is 0.96. The t-stat is 4.4, so that's highly statistically significant. The p-value is very close to 0, so our confidence in this estimate is very high. And our confidence interval, well, the beta can range. It can be as low as 0.5 or as high as 1.39 with within a 95% confidence interval. Now, the other thing to remark on is that we actually don't necessarily have to go through this much trouble if all we want is a beta, because really what we can say is just give me the slope. Then you don't actually need the data analysis add-in either. You still need to give it your range of dependent variables, the firm-specific return, the range of your independent variables, the index model or index factor returns, and that gives you the same, if we zoom in, the same 0.96 that our beta point estimate from the regression model gave. Now that we have our sort of raw estimate of the beta coefficient, the last thing we might want to consider is, do we want to adjust it? So remember, we could look at firm characteristics, create some sort of predictive regression, or if we want to do it sort of the simple shrinkage way, we can just say that if this is our raw beta, our adjusted beta is going to be 2/3 times the raw beta plus 1/3 times 1, because remember, the sort of idea is that all firms' beta tends to the long run average, and the long run average is 1. And then our adjusted beta in this case was pretty close to 1 anyway, so not a big difference, but a little bit higher at 0.97. So that's how we can actually generate estimates of beta from the returns data of a firm and our macroeconomic factor proxy, in this case the S&P 500 stock index, and how we can adjust them to sort of control for estimation error. Thanks for listening.